everyone. Myself Amitabha Majumder. I am currently pursuing my Masters in Power System Engineering under the guidance of Dr. Arvind Kumar Jain sir. So today my presentation topic is Power Quality Disturbance Classification using Artificial Intelligence. So what is the motivation behind that? Because of the injection of various non-linear loads like our computers, mobile charger. Because of that, so many kinds of power quality disturbances are taking place nowadays in our system. Various kinds like sag, swell, interruption, harmonics, transients, and so on. So to mitigate that problem, the first and foremost thing that is required to identify that particular type of disturbance. So to do that, an effective tool or some algorithm is required. So here I am going to discuss AI technique. So what is artificial intelligence? In simple words, it is a machine with human brain or mind. The capability of a machine to imitate intelligent human behavior. That is AI. And in AI, two things are there. One is machine learning, another one is deep learning. And this thing is going to discussed by my friend in next session. And in AI, the basic algorithm that is we are using, it is the ANN. So now what is the motivation of that? That is biological neuron. So in our class 10 or 12, some of us have studied that nervous system. The basic unit of nervous system is neuron. And what is there in neuron? Dendrites, cell center or the nucleus, axon, and these things. So what they are doing, the dendrites are receiving some signal, that nucleus or cell center is processing the signal, and the axon is transmitting the signal. So this thing we are implementing as artificial neural network. So here what are the topologies we are using? The dendrites are replaced as inputs, cell centers are termed as nodes, synapse is termed as waves, axon is termed as output. So whatever structure is showing here, it is the structure for single neuron. That is the X1, X2, X3 all are dendrites, and the synapse are there, the waves, and then activation summation function followed by activation function, that is your node, and output is the axon that is transmitting. Now in ANN there are mainly basically two types of ANN. First is perceptron, that is single layer, and second one is multi-layered. So in single layer, then only input and output is there. Then why it is called single layer? Because either input or output will be the activation layer, and the remaining one will be the regression layer or path fitting layer. So for that reason it is single layer neural network, and its special name is perceptron. So this neuron is very much effective for classifying linear classifications. Whenever the problem is linear or tends to linear, at that time it is very effective method. Now next is multi-layer neural network. It is the extended version of the previous one. That is, so many neurons are connected. Interconnected system of neurons. That is multi-layer perceptron also we can say that. Now, and this is very much effective for highly non-linear system classification method. And here three layers we can see. First is input, last is output. Just we are incorporating hidden layers in the middle. Hidden layers can be any number. And this is the difference between perceptron neural network and multi-layer neural network. The first one, linearly separable classes. So it can be done using perceptron. Direct segregation can be done, and it is easy one. But when there is a nonlinear system, for that we are using multi-layer neural network, and this segregation, the second diagram is showing that one only. So in node nucleus part, we have to use some activation function. What is the activation function? The activation function adds non-linearity in your system. So there are different types of activation function: log sigmoidal, tan sigmoidal, ReLU, leaky ReLU, max of ReLU. There are more than that, 20 or 25 types of activation functions are available. So any one of them we have to use in input, hidden as well as output. Basically in coding part, in the output layer only we are placing a straight line to fit the curve, and others log sigmoidal or tan sigmoidal, anything. So after building the ANN structure, so the thing is you have to train the ANN. For that some learning strategies are required. 3 learning strategies are there: unsupervised, supervised and reinforcement. Unsupervised means here you are feeding some data, non-level, and you are getting some output. That output itself is again training the neural network to get the optimal solution. Supervised one, you are giving some level data along with some desired output, and whatever output it is giving, the difference we are taking as error, and that error is feeding back to the neural network to train the system. And in reinforcement, same thing, you are going to get some data. The difference is in supervised learning we have to give desired output. Here according to the environment in which it is working, it will take reinforcement signal, and the actual output, and that difference is error, which is feeding back to the neural network and training the system. So here mainly we are actually, for classification purpose we are using supervised learning. Unsupervised learning we are using for clustering, like that things. So in supervised learning, one very good topic is backpropagation algorithm. So what is backpropagation algorithm? In our neural network, whatever neural network we are using, that is feed-forward neural network. And that feed-forward neural network, the data is flowing from input to the output. And backpropagation algorithm, whatever output we are getting, that error is feeding back through the neural network, adjusting each weight. There is some formula, it is there, that del Wij is equal to minus dou Wij of E total. That is there, and that adjustment we have to do in manual calculations, and then we will get the optimal ANN structure. So this thing we are going to use to classify signals, different types of disturbance signals. So this is the flowchart of that application. So we have to model the particular type of disturbance, then we have to extract the feature, then ANN training, and we have to test the result whether it is correct or wrong. So let's have some hands-on experience. So whatever code is there, it is corresponding to set. So after execution, it is something like that. The green is the normal voltage of maximum value of 1 per unit, and red one is the disturb signal, which peak value is less than that 1, that is below also 0.9. So this is set signal, is showing what its maximum value is more than 1.1 per unit. It is the interruption one, whose value is in between 0.1 per unit. The red one is the disturb signal. This is the transient one, and specifically it is the oscillated transient one. In transient one, we have some exponential decay function. So by adjusting that parameter, you can make it as impulsive transient also. This is the harmonic signal or harmonic disturbance. Green one again is the normal one, red one is including the harmonics, and the blue ones are the third, fifth, seventh order harmonics. And this is flicker, that the voltage magnitude is changing and it is creating itself a sine function. If you connect the upper maximum then upper minimum, it will create a sinusoidal envelope regarding. Now, if you all have laptop, then you can do this coding, and it would be helpful for you also. So now here I have taken ANN for classifying two signals. One is your normal voltage signal whose magnitude it is varying from 0.9 to 1.1 per unit, and this is the function. And next one is the interruption one whose magnitude is changing from 0 to 0.1. So these two types of disturbances I am going to segregate using this ANN structure. So let me explain. Firstly, you have to utilizing some sample frequency, you have to discretize that continuous signal. So what is the code? Here fs is 3200. It is the sampling frequency. What is the sampling frequency? Whatever signals we are getting, that is continuous in nature. So for any kind of processing, you have to discretize the signal. So you can take any sampling frequency more than twice that of the highest frequency present in that signal. So our signals, whatever we are synthesizing, that's all are 50 Hz only, but we have taken somewhat higher one, 3200. So, and after that, here second line, that NVM is equal to 0.2 into random. It is not a random function. 1,200 samples we are going to create, and plus 0.9. That is why this is creating 200 points ranging from 0.9 to 1.1 per unit, and these values we are going to use as the maximum value of the sine wave for normal. So after that, we have to write a loop for the signal, and after that here two lines are written. One is NR is equal to RMS. Now for my classification, I have taken one input as RMS value, another input as maximum value. So RMS value of Xn. Xn is the signal which I am getting utilizing the NVM. Here 200 samples are there, so 200 RMS values I am going to get. Similarly, Nm is equal to max Xn. So that one is the maximum value what is present in the signal. So these two values I am going to use for my ANN training as input, and this is the I is used to get the input pattern. Now it is gone normal one. Now the interruption one, it is we all know this, its range is from 0 to 0.1. So here again same IVM, interruption voltage magnitude, that I have taken 0.1 into random function again 1 to 200. So again 200 samples I am going to get, and again for loop for synthesizing the signal, and later on IR and IN, that interruption RMS, interruption maximum. So, and every time for a particular neural network, you have to assure that you are taking the proper input size. You can't take here in the first one you are taking 3 inputs, and here 2 inputs. It can't be like that. It should be same. After that, so since it is supervised learning, you need to specify some its our desired output value. So that is the target one, T. And how I am defining here, if the signal is normal, then the output ANN output will be 0.1. If it is interruption 1, the ANN output will be 0.2. Now this is the main coding part of ANN. It is a very basic coding part. So how we are going to train the neural network? So NET, whatever is written, it is my neural network actually. New FF, that is new means you are going to train a new neural network. FF means feed forward. I am giving the input and this will flow towards the output. So what are the parameters required to train that? First is min max of I. Why min max? Because it has to get the information regarding the minimum present and maximum present in the input, so that it can scale all other parameters. Then 2441. This is my ANN architecture. 2, it is input layer. The first one is input layer and the last one is output layer. Middle one, whatever 1 or 2 layers you are writing, that's your choice. So why 2? Because while taking I have taken 2 parameters. For that reason, here in input layer 2 nodes required. So later after that 4, it is hidden layer, and hidden layer this can be of any size. It is your choice. You can do 5, but it should be in bottleneck nature. That is, it is first increasing, then it can be stable, then it has to decrease the size of the neural network. And so min max, that is the maximum minimum present in the input, the layer structure or what should be the layer, and now you have to specify the activation functions present in the nodes. Now for input I am going to use 10 sig model, and for hidden log sig model 2 times hidden, because here 2 hidden layers are there of 4 nodes. So total 8 log sig model functions is there, and last one is pure line. Pure line is straight line. It is for only fitting the curve at the last stage. So 4 layers are there, 1 input, 1 output, 2 hidden. Similarly, you have to specify the activation function for each layer. 1 input, 1 output and 2 hidden. And last one is straight LM. That is in MATLAB coding while we are doing, there are so many types of algorithm are there in that. So I have taken train LM. Others are there, you can check that also. So this is the initiation of the neural network. Now net is equal to initialize net. Now while doing the neural network training, you have to assign the bias value and the weights of the connected between the 2 nodes. So this one, it is getting initialized by this code. Now next is net dot train parameter dot show is equal to 1. That is, whatever error signal is coming in each step, then each epoch it is going to show. For that reason here it is 1. Next is net dot train parameter dot epoch. Now how many epochs you want to train? Now I have put kept here 2000. You can put 100. You can put 1 lakh. That's up to you. And now how much bigger figure you are putting, that much higher time it will take for training. And if you are putting somewhat less, suppose I am going to put 10 epochs, then may not be goal is reached. The goal means next one. The goal means your error limit. That here I have kept 10 power minus 5. My error should be less than that. So what will happen while you are specifying the epoch and goal? ANN will stop either when any one of them is reached. If it is reaching 2000 first, then it will stop there. Or if it is reaching the error 10 power minus 5 first, then it will reach there. It won't go beyond that. So, and next is you have to now train. So now training of the ANN, what are the things you are going to use? One is net. Net means our ANN model. Input, that is what you have to give, and targeted output T. So with this you have to train your neural network. And these 2 plot is, one is for target one and next one is for validation, whether it is correct or not. Now let's run the code. It has started. Now if you see, so it is very small inside. Here 2 is written, which is the size of the input, and here also 2 input size only, along with some bias B is given here. Next 2 are hidden layers. It is of 4 and 4, whatever we have specified. And here if you see in the box, some symbols are there. These are the activation function symbols. And last one, here it is 1, that is the output one, output node, and it is a pure line, a straight line only it is showing here. And output. Now here if you see, here epochs are 2000 I have given, and my error value I have given 10 power minus 5. So here what happened, in 8th iteration only I got my error value 8.16 to 10 power minus 6. It is less than this value, so this got stopped. Now when whether it is good or bad, we have to check the regression one. Now regression is showing us 0.99985, that is nearness to 1, and regression should always be nearer to 1. It should not like that 0.5 or 0.6. If it is like that, then you have to again train with changing the parameters. It should be ideally 1, because ideally 1 means whatever your targeted output and actual output both are matching at that time.
This is that your target was also mentioned here. Now you train your system if both are matching. It means whatever you have decided, you have achieved that. If that is not matching, then there will be error. So your target is that to reduce this difference, means you are reducing the error. If error will be 0, it means your system is the robust system. Whatever input you will get, it will give you the exact output. इन में अपन चेक करते हैं ना, लोड फोरकास्ट कर रहे हैं, प्राइस फोरकास्ट कर रहे हैं, पहले मॉडल बनाना पड़ता है. मॉडल रखा है, अब उसमें आप इनपुट दोगे, तो वो जो भी देगा, that you can say that is the correct, because already you have checked during the training. Then he will go for testing also.
So this is the regression one.
यहाँ पर नेट क्या था, स्ट्रक्चर क्या था, इनको बताया कितना इनपुट कितना.
हाँ, that too. So here along with it, two more parameters are there. One is performance. Performance is what is the error level you are getting. See, the upper one, here two lines are there. The upper one is 10 power minus 5, that is your targeted error, and you have reached the lower one, that is of 8.16 into 10 power minus 6. So it is below that, for that reason is stopped. Now opposite one I am also showing you what is happening if I am reducing it from 2000 to 20, and here I am putting a error level of 10 power minus 10. Now see, it has reached its maximum epoch, for that reason it stopped. Previously it reached its maximum error limit, for that reason it stopped.
What is the meaning of epoch here? Epoch means what? Iteration. कितने बार रन करके क्या आएगा? Iteration जिसको बोलते हैं ना, यहाँ पे epoch बोलते हैं. और epoch भी कैसे जैसे कम कर दिए, तो ये उस लेवल तक पहुँच ही नहीं पाया. उसमें ज़्यादा iteration नहीं मिले ना सॉल्व करने.
ये generation.
that is a generation. In ANN it is a epoch. और in mathematics it is iteration. Simple mathematics. So ये iteration है.
So how many times you are going to iterate your system? You have to take longer time. And here also time is specified. And see, it is at that instant only you got the 20 epochs. Understood? And what happened now? Here error level it came of 3.80 to 10 power minus 9. So let's check what is the regression also. It is exactly 1. Because why it is exactly 1 and not that previous one 0.99? Because here you see the error level. It is of 10 power minus 9. Error is very less. And previous one it was 10 power minus 6. For that reason some furthermore adjustment could be done, previous one, but here it has done. For that reason it reached its regression of 1 directly. Very good fitting. And performance if you see,
So it means the monitoration has been done, then the error will increase. Not necessary.
not necessarily, because if you are going for more iterations now, it will take more time also. Maybe after certain time period, the error will get settled at a particular value, maybe higher than whatever you have defined. Okay, so suppose you have given 10 power minus 5. So maybe possible that 10 power minus 4, around that it got settled. But your iteration is going on since you have specified a very higher epoch value. So it will go on, but what will happen? This will get stable at a particular point.
It's a drawback. It depends on your application. Suppose you want to perform a task within 1 minute. Online things are there. If you will select the 2000 or 5000 iteration, it will take suppose 10 minutes. Then there is no use of this ENN, because you want to predict something within a 1 minute. and it is providing the answer after 1 minute or 2 minutes or 10 minutes. No use of it. So there is a need to optimally design the ANN in which you select the error level, what should be the error. ये भी आपकी एप्लीकेशन पे होगा. यदि आप इलेक्ट्रिकल की बात करेंगे तो यहाँ पर नैनो सेकंड में माइक्रो सेकंड की बात करते हैं. अब उसमें यदि आप 1 मिनट के बाद सॉल्व करके देंगे तो then there is no value, सिस्टम ही उड़ जाएगा आपका. So you have to set it, take a time in the microsecond or millisecond. So that may be thing. If you want to use this system for a offline application, offline में time नहीं होता है. गेम खेल रहे, अब चल रहा है गेम, जब तक चलेगा खत्म हो जाएगा तो ये offline है. If you are doing something in real time or online system, then you have to fix that time because you want to predict the thing within that time only. Then you have to select your number of iterations also, error level also. क्योंकि यदि लंबा चलेगा, जो कह रहा उन्होंने बोला ना कि 200 के बाद सेटल हो गया, लेकिन क्योंकि आपने 2000 दे दी तो 2000 तक अननेसेसरी उसी रिजल्ट को लेके चल रहा है. What is the meaning of that? No meaning of that, simply wastage of time. क्योंकि जो आंसर मिलना था वो तो 200 पे ही मिल गया. So but how will you decide that how many inputs are required? Then the process. After some time you will identify how much time is required. So this is a hit and trial method. You can solve and find out. You can select the meticulously your input also. Inputs यहाँ जिसके बाद में 50 लोग हैं, लेकिन 50 लोग एक ही काम को नहीं कर सकते. There may be 10 students who are good in that particular work. So out of 50 select those 10 only. Similarly here also in ANN there may be n number of inputs, but all are not required. So there are certain methods you find out the useful input. तो आपको complexity कम हो जाएगी ना. 50 को हटा के 10 से डील करना है, unnecessary 50 से डील कर रहा है, इनको कुछ आइडिया नहीं, इनको आइडिया नहीं तो डील कर रहा हूँ. तो once you will develop an ANN model for any application you can develop. First you select the useful input, then you select the your target because output चाहिए ना. error तो पहले target पता नहीं को हमें जाना कहाँ है, तो ANN को क्या पता कहाँ ले जाएगा, right? Then you find out the stopping criteria. Stopping criteria may be time, कितने समय बाद ये रुके. Stopping criteria may be epoch, कितने epoch के बाद ही मिले. And how will you decide? Based on your application. यदि application offline है कि online है. Offline है तो time is not a matter. आपको कितने भी चलाओ उससे भी फर्क नहीं पड़ता. if online है आपको लोड फ्लो करते हैं एप्लीकेशन हर 5 मिनट में होता है. अब 5 मिनट में यदि लोड फ्लो रन करके नहीं बता पाए तो उसके वैल्यू क्या है, 1 घंटे बाद आंसर देगा तब तक पूरा सिस्टम ही पूरा ब्लैक आउट हो जाएगा, आउट हो जाएगा, राइट. तो ये फर्स्ट because decide your target based on target and application you can select epoch and other parameters, right. So what is he is trying to give, ने पहले शुरू में बताया होगा जो मैं बता रहा हूँ वही कर रहे हैं ना कि इससे जो पावर क्वालिटी इश्यूज हैं इतने सारे आपने देखा लोगों ने कहा 16 टाइप्स पावर इशू क्वालिटी इश्यूज आते हैं. आइडेंटिफाई दो इशू एंड क्लासिफाई कि इतने सारे जो ऐसे आ रहा है इसमें से कौन सी प्रॉब्लम है, व्हिच वन इज सेट, व्हिच वन इज स्वेल और व्हिच वन इज हार्मोनिक डिस्टॉर्शन. दो यू कैन क्लासिफाई. जो आपका पावर एनालाइजर होता है ना उसके अंदर भी कोई प्रोग्राम ही होता है, कोई सिग्नल आ रहा हो तो क्या पता है क्या प्रॉब्लम है. ही एनालाइजिंग ना, तो दैट इंस्ट्रूमेंट इज एनालाइजिंग बेस्ड ऑन द एल्गोरिथम. So he is talking about the algorithm, how to develop the power quality detection and identification algorithm. ANN is the one of the thing. With the help of that ANN you can predict or classify the power quality. तो वो अभी ANN बता रहे हैं, शायद बाद में बताएंगे. है इसमें एक बार बताओगे ना क्लासिफिकेशन का.
ये तो क्लासिफिकेशन दे
नहीं अभी ANN ट्रेन कर रहे हैं ना.
ट्रेन हो चुका है.
अच्छा कुछ प्लान कर बताओ.
नहीं अभी एक और पैरामीटर चेंज करना है.
आज कर दिया.
So I am again training the system. See here error level now came to 10 power minus 11 and that too in 11th iteration. I didn't have changed any parameter. 20 previously was there, it was minus 10. Previously it stopped because of 20. Now it has stopped because of the error level. So ANN can be anything can be happen. So based upon your environment and your the system. So regression is obviously very good. Okay. Now to test the system, what we have to do?
You have taken 2 input layer, but you
One input layer with 2 neurons.
you have shown what should be fed to that two neuron, IR and IM. You haven't told the processing, the process signal.
इनपुट क्या दिया है एक्सप्लेनेशन?
That is written. Yeah, I this max RMS value and maximum value.
So how to process and get this bill?
No, these are inbuilt function. RMS and maximum value, these are inbuilt present in MATLAB. So not much effect you have to do. But where you have to do, if you are going for any signal processing technique, at that time you have to write a huge code of that particular signal processing, including integration, summation, and that window function. And after that, whatever result you are getting, obviously the whatever signal processing techniques are given, all of them are nearly giving a frequency domain one component. So something real plus j omega something will be there. So from that you have to try to extract that necessary information. Either it could be of normal deviation or power parameter, anything whatever you require as per your classification. I have taken here RMS value and maximum value for that. Now I am showing here whether it is.
बीच में मैं इंटरप्ट करता था, क्लियर हो गया?
Yeah, okay.
तो देखो, जो अभी बात कर रहे हैं, क्या बात कर रहे हैं? Signal is coming. Here he generated the synthetic signal with the help of mathematical formula. Signal is directly coming. Electricity is there. If you will connect any load, signal may be disturbed also. So that signal, there are two things. Directly you can take that signal as a image and you can analyze. That is the image processing. Have you heard the word image processing? Image को डायरेक्ट करता है. डॉक्टर जिसके पास जैसे एक्सरे दिखाने जाओ, तो डॉक्टर क्या एनालिसिस करता है? ठीक है, तो इमेज को देखकर बताता है. उस इमेज को आप कंप्यूटर प्रोग्राम बना दो. If that image will pass through the computer, then computer can also predict these days. So in place of doctor, you just upload your X-ray on the website. There are certain websites, and they will analyze it and give you the result what problem you are having. That is the image processing. Same is applicable here also. In this case, what he is saying, whatever signal is there, first we apply a signal processing method to analyze of them, attract the feature, and out of those, with the help of so much mathematics, digital signal processing or we have had the simple FFT and other methods, so we apply and extract the features from that signal. Those features you can use as a input to the ANN. So that ANN will compare. Suppose that he told in the sinusoidal wave, if suppose that the maximum equal to 1, right? That 1 may vary for voltage I am talking about. The maximum is 1. That voltage may vary between 0.9 to 1.1. तो यदि अपना इतना 10% प्लस माइनस होता है तो अपन क्या बोलते हैं? वोल्टेज इज नॉर्मल बोलते हैं नहीं. यदि वो वोल्टेज सपोज करो 1 की जगह 2 हो जाए, 220 की जगह 440 हो जाए, तो क्या हो गया? एबनॉर्मल हो गया. 110% से ज्यादा या 90% से कम जो भी होगा वो एबनॉर्मल होगा. तो ये यहाँ पे क्या करेंगे? तो मैक्सिमम वैल्यू है, आरएमएस वैल्यू है, उससे कंपैरिजन करेंगे. अपना जो वेव होता है वो कौन सी वैल्यू होती है? 440 या 220 बोलते हैं, कौन सी वैल्यू होती है? आरएमएस वैल्यू, इफेक्टिव वैल्यू होती है ना, आरएमएस वैल्यू. तो एक वैल्यू है, उससे कितना परसेंट ज्यादा कितना परसेंट कम गया, उसी से तो आप पता लगाओगे ये सहज है कि स्वैग है. तो वो फीचर्स को सिलेक्ट किया, उनको इनपुट लिया, फिर एएनएन से जो ओरिजिनल होगा उससे कंपैरिजन करेंगे. समझ जाते हैं ना? तो डॉक्टर भी बहुत सारी चीजें लगा देता है, फिर बता देता है आपको ये प्रॉब्लम जो कि माइक्रो वोल्ट अपने अंदर भी है, तो वो कंपैरिजन. तो आप क्या करते हो? हेल्दी चीज से किसी अनहेल्दी चीज को कंपैरिजन करते हैं, जो डेविएशन होता है वो प्रॉब्लम बताता है. सिमिलरली हियर हो, एक नॉर्मल है आपके पास आरएमएस वीएमएस से भी रेंज है, इस रेंज में है तो एवरीथिंग इज फाइन. विद इन दैट रेंज जाएगा तो क्या प्रॉब्लम है? वाल्टी प्रॉब्लम है. तो वोल्टेज से कम में देखेंगे अपन करंट की कम में वाल्टी का पता चलेगा. तो ही इज डूइंग दैट. सो ही इज गोइंग टू कंपेयर विद मैक्सिमम आरएमएस ही लिया आपने इनको.
मैंने मैक्सिमम लिया है तो एक्चुअली nothing is there, just a maximum value divided by √2 is the RMS value. So for sinusoidal it is constant, so you can take anything, right? Just √2 factor is there, nothing in that. So now I have done the testing of the training of the ANN, so I have to validate whether it is true or false. So it is the code for validation. So firstly I have to take some random sample to check whether it is correct or not. So here two things I have done here. So two things I have done. First is global test. What global test? Actually in MATLAB, if you are using any variable everywhere, not in one program, all other programs also, so you have to define that variable. So here that variable is test and it is globally defined. So now I can use this test variable anywhere in any code. And now, so the function is normal select swell interruption test sample. So let's suppose I am taking one value of 1.05. Okay, so this is coming under normal range, normal voltage, and in ANN training for normal one I should get 0.1. Okay, so let's check. Firstly I have to now shown. So this thing, now whatever two inputs are required for the ANN training, so two inputs I got. Now thing is sim, it is the simulation of what? NET, that is ANN structure with respect to my test data. Now it is coming 0.1, so it is directly giving it is a normal voltage. Now similarly I am again going, suppose now let's interruption is there, so interruption is 0.0 to 0.1. So let's check 0.06. Okay, so it is interruption. So what should I get? Let's check. Now two input parameters I got. Now I have to fade again. Sim, again sim, net, test. Answer is 0.2. Now let's do another thing. Now for interruption I have taken 0 to 0.1, for normal 0.9 to 1.1. Now let's take 2. 2 is not present anywhere in the ANN structure. So let's check what it is showing. It is showing 0.1. Why? Because 2 is nearer to 1 or nearer to 0.9 to 1.1. Because of that it has gone to 0.1. But actually it is so not true. 2 means some kind of swell. Since swell code I didn't have incorporated, for that reason it has not gone to that category. It has came to normal category. Now if I am going to give suppose 0.2, okay, that one also is not present in ANN. 0.2. So let's check where it is going. It is going 0.2003. That means in interruption part, because it is nearer to interruption. So for sag and swell you have to also write the code and you have to train the model with these parameters or say some other parameters also to check whether it is correct or not. So this is the thing, and I have taken here actually 2 parameters. You can take many more also, but if you are getting good results with the lower parameters input, so what is the requirement of getting for higher input values? So this is the thing, and I can show you another one also. Suppose now here these 2 lines are for sag and swell. So here I am now going to classify 4 disturbances. One is interruption, one is sag, normal and swell. Interruption ranging from 0 to 0.1, sag from 0.1 to 0.9, normal is 0.9 to 1.1, and swell is 1.1 to 1.8. Now let's train the model, but before that I have to change the parameters. I am putting here 2000 and 2000 is my epoch value and error is I have put it -10. Now let's run the system. Yeah, error has shown. Why? Because I didn't have to change the target. Here, the target I have to change. Now, what is the target? For normal, it should show 0.1. For sag, it should 0.2. For soil, it should 0.3, and for interruption, it should 0.4. Now let's train. Training started, and if you see, the epochs reached of 685 around, and my error level is 9.93 to 10 power minus 11. So here, which one reached? Error level reached. Because of that, it stopped. Maybe it can be up because of the epoch also. So now let's take regression. 1. Okay. If the ANN training is stopped because of error level reaching, then your regression must be 1. Always. And if it is stopping because of the limit excitation in epoch, then it may not be 1. It may be 0.9, 0.8 also. So now 4 categories I have subdivided. Now again I am doing now say any value from 0 to 1.1, any value, anything audience can give. 0.87. So it is coming under which category? It should come under sag quadrant. Sag. So sag means your sag means your output should be 0.1. It should 0.2. It should show. Let's check. I forgot to do this global variable. 0.87. How much is it showing? So it is sag.
This is a classification. Have you heard about classification?
Just classifying the different kinds of faults or different interactions.
Different type of power quality. So there's sag, soil, harmonic. So he considered 4.
4 here.
0.1, 0.2, 0.0.
Anything you get, but it should not. The output should not be more than 1 value. Because since all the activation functions are in the form of e power minus x or like that, so obviously if you are feeding some data more than 1, the output will be below 1 itself. So every activation function is giving the value of below 1, and later on you are asking for some higher value of more than 1, so it won't possible. So
if classification category is only 2, then you can go 0 and 1.
yeah, that thing
Number of more, then you have to follow this.
follow with decimal values you can do. Maybe it is 0.001, 002, that one also you can take for higher levels, not a big issue. But it should not be like 1, 2, 3, or 100, 200 like that. Then
ANN is what? This machine learning application. Machine is learning directly from whatever is coming data, is analyzing and giving you answer. That is the problem. So this is it up to classification.
yes, sir.
Monitoring is also possible. Now, who is classifying this? The machine is classifying. But that information should reach to someone. ना? आपके इलेक्ट्रिकल सिस्टम में तो कोई ऑपरेटर है, कोई ऑपरेटर, किसी को पता तो चले कि ये कहाँ पे प्रॉब्लम हो रहा है, तो क्या प्रॉब्लम हो रहा है, तो वो मॉनिटर करेगा. इसमें एक और है जो शायद अभी इनके में नहीं है, प्लेस भी पता चले प्रॉब्लम क्रिएट कर कौन सा. That is also a in the system. Suppose there are 100 of machine, which machine is creating the problem? आपको अभी जैसे उन्होंने बताया था इन्वर्टर हो गया. Inverter is also electronic device. It is creating problem. Now there are hundreds of inverters, hundred of machines. Where the problem is coming? So location may be issue, classification may be issue. So detection, what kind of problem? Detection, classification, location, monitoring, all are the part. So there may be a specific device may come in the future. By sitting in the control center, he can check the particular place is creating the problem, who is responsible for it.
Sir, like in case of PV system, where sir, say in four modules, there is a shading, partial shading numbers. In that situation, how will it detect that which module or which array the partial shading numbers?
So you have to need to predict. So in the same way, you have to design.
For that, what you have to do? Again, say what are the parameters are there for a PV module, PV, single PV. You are saying that or not?
Not single PV.
Module also,
Yes,
some module is there. So some rated outputs are there, current or voltage or something. So you have to fed that information to that ANN module. So correspondingly, until and unless it is getting violated, the same value will come. So your required value is 0. So it will give 0, 0, 0 every time, whatever. But if anything disturbance is occurring, so obviously the value gets changed. So at that time. So by that you get to know the
Suppose 100 cells are there. So you connect in a particular fashion.
Because
every time they will give the 0, 0. If suppose your cell number 10 is not performing, then their output will be different.
yeah.
You can check
It is not like that here directly it will be written that it is a set, because it is ANN, it is a mathematical function only, everything is mathematics. So obviously whatever output input is there, all are numbers only. So by number, seeing the number, you have to decide. It is not like that here 0.2 by that, and by the previous knowledge we can say that it is a set. It is not like that it will directly show that it is a set. So for that coding is required. That is coding, and it is the mathematical analysis. So actually,
there will be one session on Thursday. So then the such type of mathematical thing will not appear. Direct image will go and it will predict what kind of image it is, what problem it is. So that session is also. This is the one thing, mathematically analyzing and doing the thing. Second is direct image. You put the image, it will give the answer. So that session will be held on Thursday from 10 to 11:30.
and
But both way, whatever way you want to do, you can do.
And the working is not that much simple that you are thinking like that ANN is just you are putting and it is getting trained and like not like that. For that you have to take one simple network of 2:3:1 and you have to solve all the ways what is coming, at least 1 or 2 iterations, then hand on based on hand on paper, then you get to know that how it is actually working. But just seeing only this is working, no one can get any idea regarding that. And it will give the result, but what the result, how it is giving, you can't understand anything.
So अभी कैसे एक पता चल गया? So सारे चल पता चल.
हाँ, पता करते हैं. Suppose मैं देता हूँ 0.94. It is coming under normal. चेक करते हैं चलो. 0.1 ये normal का था.
Point 1 is coming to normal. Point 2 is coming to second.
हाँ, 0.2 is
और swell.
0.3.
और fourth one is
0.4 interruption. So suppose it is 1.54. Now it is swell.
swell. 1.1 always is swell.
Swell, okay.
डेढ़ गुना हो गया ना voltage. Higher voltage.
0.300.
Interruption. Interruption means क्या देना पड़ेगा इनको?
हाँ 0 देख सकता, देख लेता है. 0 एक्चुअली 0 देता है. See 0 दिया है, ये जो सा RMS भी 0 है, मैक्सिमम भी 0 ही है सिग्नल का.
इंटरप्शन मींस ऐसा लाइन अब ये तो एक है, इन्होंने एक किया है, इससे आगे रिसर्च आती है. तो एक सिग्नल में 2-3 टाइप की भी प्रॉब्लम हो सकती है. कुछ देर के लिए वो ऐसे में प्रोटेक्ट हो जाए, फिर सोल्यूशन आ जाए, तो कैसे प्रोटेक्ट होगा? दैट इज आल्सो पॉसिबल. सम मोर मैथमेटिक्स से वही होता है. पहले ट्रांसलेट द स्टैटिस्टिकल. दिस इज द वे ऑफ अंडरस्टैंडिंग. यदि 4 का एक बार में बता दें ना, तो आपको कॉम्प्लिकेटेड रह सकता है. नाउ यू कैन kill up the signals, and you can train the signal in the ANN. Then ANN will predict it.
But for that reason, suppose maybe it won't be helpful with these 2 inputs, that whatever maximum RMS. Suppose you are clubbing 2 or 3 signals. So obviously what will happen, suppose if I would have been incorporated here harmonics, what is the thing is that harmonics, if you consider its RMS value is coming in the range of sec, okay, in most of the times because of the deep and low higher order harmonics. So maybe if you are giving any harmonic signal at that time, it will detect it as sec, not harmonic. So by understanding that, you have to change your input parameters then. So means utilizing RMS, you are not getting the correct answer. So you have to incorporate another parameter from the signal. If it is not working, then another one. So in this way, 4 or 5 parameters you need to incorporate for this. This is very, even I have used 2 1. If you are going to use a single parameter also, that would be, it would be same one only it will give. But it need not be that much bigger parameters you are giving. You are giving 100 input parameters to segregate one event. It's not like that. It will take very high processing time also for the system. Optimization is required.
Now your system should be robust as well as simple. यदि बहुत complicated होगा तो फिर वो self trapping मतलब वो trapping हो जाता है. Overlearning, underlearning होती है, इसमें issue होता है. तो ANN is based machine learning is very useful. You can apply in anywhere. Parameter tuning or any prediction, classification, feature extraction, anywhere. This is the tool which is applicable in all kind of problems, whether it's electrical or electronics or computer or finance, whatever you want. Even weather prediction. So how they are predicting the weather? Only help of this ANN. They have the previous year data, temperature, humidity, each and everything. They have trained a model. Now it will collect the data after 1 hour. What will happen? They are predicting and showing you. 100% सही नहीं होता है. वो कई बार बताते हैं there will be rain at 4 o'clock, but there will be no rain. क्योंकि in front of nature everything is there. ये तो artificial intelligence है, so predict. लेकिन हाँ, these days 99% are true. मैंने ये सब देखा. IPL हो गया. साउथ अफ्रीका में मैंने बताया. And commentator told that at 7:25 there is a prediction there will be rain at 7:25. Exactly at 7:25 there will be rain. So such a robust model also are there. But for creating a robust model, there is a need of robust data because it is learning from the data. ANN कैसे learn करता है? ANN just like a kid. किड कैसे लर्न करता है ना, उसको एबीसीडी आती ना, आवाज आता ना, आपकी लैंग्वेज में कुछ नहीं आता, फिर वो कैसे लर्न करता है? Just like hearing or watching the thing. Just watching the thing. If we will show, don't touch this. This is harmful. वो understand करता है, don't touch. So you will show him the pattern. If he will do this, then that will happen. So he has learned so many things without doing any mathematics, ABCD, nothing. But he will learn. He or she will learn everything. Because just watching. If this happen, then this will happen. If I will do, then my parents will scold me. If I will this, my parents will award me. So, is there any mathematics is required? No mathematics is required. Now machine doesn't have the brain. So machine see the data pattern. If x1, x2 is the input, then what will be the output? The output you are showing, input also you are showing. So that is a one pattern. x1, x2 equal to y. तो उसने x देखा, x2 देखा तो y ये होता है. फिर x1 की वैल्यू ये होगी, x2 की अनदर वैल्यू ये होगी तो y होगी. ऐसे आपने 1000 डेटा दिखा दिया. अब उन डेटा के बीच से कोई भी x1, x2 आएगा तो वो y बता देगा, फिर उसको y की जरूरत नहीं है. नाउ ये अंडरस्टूड. यदि x1, x2 ये होता है तो y क्या होता है? आंसर पता है? दैट इज कॉल्ड द इंटरपोलेशन. इंटरपोलेशन मतलब उस रेंज में जिसमें आपने सिखाया है, उस रेंज में कोई भी नया डेटा भेजोगे वो ये आपको प्रेडिक्ट करके बता देगा. फिर एक आता है डीप लर्निंग, जो वो नेक्स्ट उसमें करेंगे, वो डिस्कस करेंगे डीप लर्निंग वाले, जो इमेज के लिए करेंगे. तो डीप लर्निंग में वो इतना डीप हो जाता है कि जो आपने 1 से 1000 के बीच में सिखाया ना, तो आप 1 के पहले का 1000 के बाद का भी कुछ नंबर दोगे तब भी वो प्रेडिक्ट कर देगा. तो वो डीप, उसकी लर्निंग जो इतनी डीप हो गई कि जो नहीं सिखाया वो भी प्रेडिक्ट कर देगा. कर देते हैं. कई बार हर चीज अपन को नहीं पता होती, कुछ अपना ब्रेन एनालिसिस करके नहीं बता देता है कि नहीं ये प्रॉब्लम है. ऐसा होता है ना. सेम थिंग इज बिकॉज़ दिस इज आर्टिफिशियल. This is also intelligent. We have the natural. This is the artificial. Right. So in this way you can utilize anywhere. But what is the requirement? You develop a very good model. How to develop a good model? सबसे पहले first select the useful input. Unnecessary inputs में use आई कर रहा है. Then you select the number of neurons in the hidden layer. How many? क्योंकि number of hidden layers और neuron कर दोगे तो training change हो जाएगी. Right? Then you find out the exact target. What is your target? अक्सर की लाइफ में क्या होता है हमें पता ही नहीं होता टारगेट क्या होता है. इसलिए तो अपने यहाँ यहाँ होम करते हैं. अगर टारगेट पता होगा तो then you will align to that target, and that alignment of target is regression. Because you have the target and you are training your data in such a way that whatever output is coming that is aligned to the prefixed target. यदि इतना है तो ये error. यदि ये दोनों मिल जाएंगे तो इधर क्या हो जाएगी? You have achieved 100% target. If 99.9 also, that is also good. 99% is very high target. आप कह सकते हो कि मेरा मॉडल है 99% प्रेडिक्ट कर सकता है. Whatever answer is coming, that is true. What is the confidence level? 99%. You can say still there is a 1% chance of failure because somebody upper side is also there. जिसके हाथ में क्या होगा? So you can use anywhere you can predict. But for developing the neural network data है. जितना अच्छा डेटा आप उसको शो करेंगे वो उतना ही अच्छा ट्रेंड होगा. Right, so this is the और कुछ आप बता सकते हैं?
और फिगर कुछ नहीं
ज़्यादा नहीं काम करना.
चलो
I
इसमें
think you can understand.
तो इसमें एक दिखा देते हैं कि सपोज hello, suppose I am going to change here this model from 2000 to 200, and suppose I am going to increase my error level somewhat more of 10 power minus 20. That is negligible amount. Now let's check what is the training ratio. 200 reached, but the error level is only up to 10 power minus 7. So regression would be 1. Let's check once. See, regression is not 1 actually. Some percentage is left over. So suppose I am furthermore reducing my epoch level. Now it is suppose 20. Error is only of 0.2%, very less. Regression won't be that much good also now. 0.91203.
Now there is an error.
Very high because regression is not that much near to 1 also. Very huge difference is there. And if it is from the graph also it is visible. See, the dotted line is the actual the targeted one, but you have reached only the blue one up to that, not that much alignment. So because of that, what will happen if you are going to feed in the data? Suppose so I am giving 0.85. It should come in under category. Let's check. Same 0.1227. So you have to yourself rounding it up to 0.1. It is nearer to 0.1, but 0.1 is corresponding to normal, but your given input is sag. It is because of the error, because it has didn't have reached that much error level. You have given a sag, but you have got the information of normal. That is the problem. If you are reducing your epoch numbers.
Maybe it means that proper training is not there.
No, proper training is not there.
कुछ भी बोल रहा है, बोलते ना कुछ भी कुछ भी बोल रहा है, तो ये वैसा हो गया. तो ये अपन ने सेट कर दिया, किसका सेट कर दिया?
हाँ, सेट कर दिया था.
और इसमें कुछ और ही बता दिया. तो ये
हमने सेट किया था. इससे बोलते मतलब तुम्हारा राउंड ऑफ करो तो 0.1227, that is rounding up to 0.1 only. So it is normal.
but it is not normal.
But it is not normal.
It shows that training is not proper. your model is not robust model.
So you have to not change the parameters. Either you have to increase or decrease anything, then your choice.
Your error should be very less, not 100, 99 point something percentage accurate one. The error should be 0.025. Only 0.5%, 0.5, the 0.005. Like that.
Then think whatever you. But say it is for the health calculation. This is
and that error is only for the testing, not the training. Training में तो error होगा नहीं तो वो तो error free हुआ ही नहीं training का. Training should be 100%. Testing में रहता है, right? कुछ system को वो ना identify कर पाएगा 100 pattern दिया. अब 100 में से एक आध pattern miss कर गया वो नहीं आता 99%. टेस्टिंग में लेकिन ट्रेनिंग तो आपको ऐसे देना है कि 100 कैंडिडेट पैटर्न है तभी तो टेस्टिंग कर पाओगे. So training error is a one thing and testing error is a different thing.
And here one other problem is that extrapolation is not possible. Extrapolation, suppose if you are going for any non-linear equation, suppose 3x plus 4y plus 7, something you are putting, and suppose you are doing the NN training for the input values of 0 to 1 only. You are doing. If you are giving any value in between 0 to 1, then the answer is very good. But if you are giving any value beyond this range, then obviously some garbage value will come. See, you will see that thing.
That is what the extrapolation. इसके लिए वो ट्रेंड नहीं है वो वैल्यू नहीं देगा.
One thing can be shown. Suppose you are going for only 20 iterations. So after that, one graph is coming out. The red is the targeted one, and the green is the validation with the system. So if you see, the targeted one is the blocked one. 0.1 for normal, 0.2 for sag, swell, interruption. But what is happening here? The green is the actual one with the 20 epochs only. Now the same thing, if I am just increasing the epochs, very good overlap of the actual data and the predicted data also.
From your side.
So a big round of applause for Amitabha Majumder. Thank you, Amitabha, for presenting such informative and interesting topic.
Additional, if you have any query, you can ask.